Have you ever wondered what secrets lie hidden in the crushing blackness of the deep sea? We often imagine it as a desolate, lonely place, home to bizarre, solitary creatures. But what if I told you that, even in this extreme environment, the power of community, of the group, is just as vital as it is on the sunny savannas of Africa? Today, we re-diving thousands of meters below the surface to explore one of the most fascinating survival strategies in the animal kingdom: swarm behavior and group-based protection in the deep sea. The deep ocean is the largest habitat on Earth, yet it's also one of the most hostile. There's no sunlight, the pressure is immense, food is scarce, and predators lurk in the dark. For a small, vulnerable creature, it seems like an impossible place to survive. So how do they do it? The answer is simple, yet profound. They stick together by forming massive groups, or swarms. These animals transform from easy individual targets into a formidable, coordinated superorganism. It's a classic case of strength in numbers, taken to the extreme. Let's start with one of the most common swarmers of the deep, krill. These tiny crustaceans are a cornerstone of the ocean's food web. Individually, a single krill is a bite-sized snack for countless predators. But when they gather in swarms that can stretch for kilometers and contain billions of individuals, the story changes completely. This dense cloud of life creates what scientists call sensory confusion. For a predator like a whale or a seal, trying to single out one krill from a swirling mass of millions is like trying to catch a single raindrop in a thunderstorm. The sheer number of moving targets overloads their senses, making it incredibly difficult to launch a successful attack. This is the dilution effect in action. The odds of any single krill being eaten are drastically reduced simply by being part of a huge crowd. It's a game of statistics, and in the deep sea, it's a game that saves lives. But it's not just about hiding in plain sight. These swarms are not just random gatherings. They are highly dynamic and responsive. When a threat approaches, you can observe a ripple effect through the swarm. A wave of movement, a sudden contraction, or a change in direction can propagate through the group at astonishing speed. This coordinated evasion is not centrally controlled by a leader. Instead, it's an emergent property. Each individual follows a simple set of rules, like maintaining a certain distance from its neighbors and mirroring their movements. When one animal reacts to a predator, its neighbors instantly react to its movement, and their neighbors react to them, creating a cascade of evasive action that moves the entire swarm out of harm's way. It's a beautiful example of decentralized intelligence, where collective safety emerges from simple local interactions. Let's move on to another fascinating example: the bristlemouths, or lanternfish. These are some of the most numerous vertebrates on the planet. During the day, they reside in the deep, dark twilight zone, but as night falls, they undertake the largest migration on Earth. Billions of them swim upwards towards the surface waters to feed under the cover of darkness, and then descend back into the depths before dawn. Traveling together provides protection from predators that hunt at different depths. By moving as a cohesive unit, they benefit from the same dilution and confusion effects as krill. Furthermore, many lanternfish have photophores, light-producing organs on their bodies. From below, these lights can help them blend in with the faint light filtering down from the surface, a type of camouflage called counter-illumination. But in a swarm, these lights can also be used to confuse predators. A synchronized flashing or a sudden blackout by the entire group can startle an attacker, giving the swarm a critical moment to escape. The strategy isn't just about avoiding being eaten, it's also about finding food more efficiently. In the vast, sparse environment of the deep sea, finding a meal is a huge challenge. Swarming can increase the chances. A large group covers more ground, and when one individual finds a pocket of food, its feeding behavior can signal others to the location. This collaborative foraging ensures that the group as a whole can capitalize on scarce resources more effectively than a lone individual ever could. Some deep-sea squid species also form groups. While they might compete for food, the protection gained from schooling together outweighs the competition. When threatened, they can release a cloud of ink simultaneously, creating a much larger and more disorienting smokescreen than a single squid could produce. This collective defense mechanism is a powerful deterrent. Now, let's consider the predators. How do they counter this incredible group defense? Some have evolved equally impressive strategies. For instance, bubble net feeding by humpback whales is a direct response to krill swarms. A group of whales will swim in a shrinking circle while blowing bubbles below a school of krill. The rising bubbles form a net that corrals the krill into a dense, tight ball. The whales then swim up through the center of the net with their mouths wide open, engulfing thousands of krill in a single gulp. As prey develop better group defenses, predators evolve more sophisticated group hunting techniques to overcome them. Another fascinating aspect of deep-sea grouping is seen in glass sponge reefs. These are not swarms of moving animals, but ancient, slow-growing colonies that create massive three-dimensional structures on the seafloor. These reefs, built by countless individual sponges over thousands of years, become vital habitats. They provide shelter and a safe haven for a huge diversity of other deep-sea creatures, from fish to crabs to shrimp. In this sense, the sponges are creating a protected community. By forming a group structure, they fundamentally change their environment, creating a city in the deep that offers protection to countless other species. It's a form of group-based protection that benefits not just the sponges themselves, but an entire ecosystem. So, what can we learn from all this? The behavior of these deep-sea swarms shows us that cooperation and community are fundamental principles of life, even in the most extreme and seemingly isolated places on our planet. The simple act of staying together, of moving as one, can mean the difference between life and death. It allows these creatures to navigate a dangerous world, find food, and raise the odds of survival in their favor. It's a powerful reminder that there is incredible strength in unity. From the tiniest krill to the most ancient sponge reef, the deep sea teaches us that working together is not just a choice, but a masterclass in survival, engineered by millions of years of evolution in the dark. The next time you look at the ocean, think about the unseen world below. It's not just a collection of individual monsters of the deep. It's a world of vibrant, dynamic communities, of billions of creatures moving in a silent, synchronized dance of survival. It's a world that shows us the profound and universal power of the group. Thanks for joining me on this deep dive today. If you found this journey into the abyss as fascinating as I did, make sure to hit that like button and subscribe for more adventures into the wonders of our natural world. Let me know in the comments which deep-sea creature you'd like to learn about next. See you in the next video.